Hi everyone, back again. This is a review of AQA Foundation Paper 3 for Maths 2025, based on what students have reported. This is fair use for educational purposes. So, first three patterns in a sequence, we've got them here, and we're being asked to draw pattern 4. So I'm seeing 1 block, 2 blocks, 3 blocks. So I think I want 4 blocks in there, and then X's all around. So our answer should look something like that. How many X's are in pattern 6? Well, looking at what I've got going on so far, in pattern 1, I've got 1, 2, 3, 4, 5 X's. In pattern 2, I've got 1, 2, 3, 4, 5, 6 X's. In pattern 3, 1, 2, 3, 4, 5, 6, 7. Noticing a pattern. In pattern 4, the one I've drawn, that is 8 X's. So in pattern 5, there would be 9 X's. So in pattern 6, which is the pattern in question, there would be 10 X's. So 10 would be our answer. We had some sort of combination question, I think, about delicious cheese sandwiches or other fillings are available. So sandwich choices, 1 bread, 1 filling. So I've got white or brown, cheese, ham or tuna, and I was asked for all 6 combinations. So that should have been white with cheese, white with ham, white with tuna. So that's all the white ones I could have. And then the same for brown, really. So brown with cheese, brown with ham, brown with tuna. What fraction use cheese? Well, it's these two that use cheese. So that is 2 out of 6 or 2/6, which I'm going to simplify to 1/3. But depending on how many marks, you might have been all right with that being 2/6. I imagine that's just a 1 marker so early on in the paper. Right, number machine. So I've got an input, times 3, take away 5 is my output. Work out the output when the input is 4. So if my input is 4, 4 times 3 is 12. Don't forget to use your calculator if you're not confident. Here's a calculator paper. And then 12 take away 5 would be 7. So my output should be 7. Work out the input when the output is 19. So this time I'm going backwards. So I'm going to say I'm starting at 19. I'm doing the opposite of take away 5, which would be add 5, which would get me to 24. Then I'm doing the opposite of times 3, which is divide 3, which should be 8. So I think the input should have been 8. Right, complete this number machine. 16 goes in. I add 2. Well, that gets me to 18. And then the output should be 3. So I think that actually there's a couple of different answers we could have here. I would go for minus 15, or I suppose we could have divide by 6. Either of those would give me the output of 3. All right, some fraction, decimals, and percentages. So if my decimal's 0.5 and my percentage is 50%, what's that as a fraction? I think that's a half. 1/10 or 10% as a decimal, 0.1. And 2/5 or 0.4 as a percentage, 40%. What percentage is shading? A couple of different ways you could think about this. For me, I've got 4 columns, so each column must be worth 25%, because then that's getting me up to 100%. So 3 of those must be worth 75%. Loads of different ways to think about that. Right, then I've got some metric distances, and I'm being asked which is the most appropriate measure. So distance between villages, I think could be kilometres. Length of the pencil, centimetres. Can you imagine a pencil that'd be 1 metre long? That'd be crazy. Height of a building, metres. Right, then we had a bit more of a practical question. We're looking at 2 different phone plans. So I've got plan A, 500 quid for a phone, plus £11 a month for 24 months. Or plan B, a free phone, 35 quid a month for 24 months. Show that plan A for 24 months is £764. So that's nice, I know what I'm shooting for. So plan A, I think that's £500 for the phone, plus £11 for 24 months, so 11 times 24. going to grab my calculator and bang that in. So I've got 500 plus 11 times 24. Using my brackets there because I want it to do that 11 times 24 first. 764. Lovely, because that is what I am expecting. Nice. Plan B is reduced by 10%. Which one is cheaper? Well, on Plan B, it's £35 for 24 months. So let's find out that price first. So 35 times 24. I've added them there. Come on. 35 times 24, 840. So the whole thing's going to cost me £840, but I have got a 10% discount. 10% of that would be £84. So if I do that as my discount, 840 take away 84. So I've got 840 there already on my screen. Take away 84, £756. Right, one burger costs £3.80, 2 burgers and 3 hot dogs cost £15.85. Work out the cost of one hot dog. Well, if one burger costs £3.80, 2 lots of £3.80 would be £7.60, which I think is 2 burgers. I'm just going to put B for sake of ease. So if I do the full price, take away my 2 burgers, that should leave me with 3 hot dogs. So £15.85, take away £7.60, should be £8.25. Again, use your calculator for everything in the calculator paper. No point in making a silly mistake. So that's my cost for 3 hot dogs. 1 hot dog, I must divide that by 3. So 8.25, £8.25 divided by 3, £8.25 divided by 3, £2.75. Right, the square of a whole number is a 2-digit number. What is the smallest and largest number? Well, 3 squared is 9, which is not enough. 4 squared is 16, so that's my smallest one. And then 9 times 9, 9 squared is 81. That's going to be my largest one. If I go any larger than that, I'm going to be at 10 squared, which is 100, which is a 3-digit number. So 4 is my smallest one, and 9 is the largest one. Nice question here. Which is larger, 0.8 squared or 0.8 cubed? So I'm just going to reach for my calculator. 0.8 squared is 0.64. 0.8 cubed, 0.512. So that one is the larger one. Right, if I've got £4.56 using the smallest amount of coins, what is the modal coin? Now, modal, just that posh word for most, for mode. So, using the smallest amount of coins, so I want to go for the biggest coins I can, so I think £2, and £2 gets me up to £4. 50p, 5p and 1p, so the mode's the one that happens the most, which is the £2 being the mode. I've got 5 numbers, 5, 9, 4, 16, 8. One number is added to make the median 7. What is that number now? The median is the middle one in the middle. So I'm just going to write these numbers out in order first. So I've got 4, 5, 8, 9, 16. So at the minute, my middle one is 8. If I want the middle one to be 7, I'm going to need a 6 there, because then halfway in between 6 and 8 is 7. So 6 is my added number. Okay, if I'm buying plates, there's a question about buying plates. Someone's buying plates for the restaurant. They've got 20 tables. They want 6 plates per table and an extra 70% for spares. How many plates do they need to buy? Well, 20 times 6 is going to be my base amount for my tables, which is 120 plates. I'm then going to want to figure out what 70% is and add that on for my extra. So I'd start by saying 10% would be 12. So 70% must be 84, because I'm timesing by 7 there, and 12 times 7 is 84. Again, use your calculator for these things. So I've got 120 plates as my base level. I've got my 70% extra, so I just need to add them together. So 120 plus 84 should be 204 plates. All right, work out the ratio of the area of the rectangle to the area of the triangle. Now, a couple of ways you could do this. You might count the squares, since it's on a nice centimetre grid for us, so we could use the formula. So if that's 5 and that's 3, area of that is 15 centimetres squared. If that's 4 and that's 4, for a triangle, base times height and half it, so 4 times 4 is 16, half of that is 8. So my rectangle to my triangle is 15 to 8. I can't simplify that. The only thing that goes into 15 is 5 and 3. Neither of those fit into 8. So we're done on that one. Right, a box contains counters that are red, blue, green, or yellow. And I've got this table showing me those colours along with their probability. I get told that the probability of green is the same as the probability of yellow. Complete the table. Well, we should know that probabilities add up to 1, so let's see what we've got so far. So 0.1 add on 0.24 is 0.34. So if I take that away from 1, that must be what those two are together. So 1 take away 0.34 equals 0.66. So those two together add up to 0.66. They are the same as each other, so I'm going to half that to give them the same value. So 0.66 divided by 2 is 0.33. So the chance of green must be 0.33. The chance of yellow must be 0.33. If I was doing this exam for real, I would add those up. For real, I am sort of doing it for real. I'd add those up and make sure that they added to 1, because that would fill me full of confidence that I've got it right. Right. I'm told I've got 600 cards in the box. How many are not blue? Well, if I've got 600 cards and the chance of pulling out a blue one is 0.24, if I times those together, that will tell me how many blue ones I've got. So 600 times 0.24. You see that all right? 600 times 0.24 equals 144. So that's 144 blue cards. So there's 600 cards in total. If I take away my amount of blue cards, that must give me the amount of cards which are not blue, which would be 456. Right, I've got two triangles, A and B, and I've been given some facts about them, and I'm being asked whether they are always congruent, sometimes congruent, or never congruent. Right, A sides are equal to B sides. Well, that's our side rule for congruent, so they must always be congruent. A's angles equals B angles. I think that's sometimes congruent. I could have two triangles with the same angles, but also I could have with the same angles a much larger triangle if it was an enlargement, so only sometimes. A is an enlargement of B. Well, if it's an enlargement, it is not the same, it is not congruent, so that'd be never congruent. After that, we had this one about perimeter. So here is an equilateral triangle. Find the perimeter. So I'm being told that that side's 6x minus 8 and that that side's 2x plus 12. Well, if this is an equilateral triangle, I know that all sides are the same. So I'm going to start by saying that that side is the same as, is equal to the other side. So I'm going to solve this to find out what x is. So if you've got x's on both sides, always get rid of the smallest amount of x. So take away 2x would give me 4x minus 8 equals 12. Now if I get rid of the minus 8 to try and get that x on its own, so I'm going to add 8, give me 4x equals 20. 4 times the number is 20. that number must be 5. So if I know that x is 5, 2 times 5 is 10, add on 12 is 22, so that side's 22. I'm just going to check it over here, because if I've made a mistake I can find out. 6 times 5 is 30, take away a is 22, so I can be pretty sure I'm on the right track. 3 sides that are all 22, so 22 times 3, 66 centimetres for the perimeter of that triangle. Right, Shay and Nala throw a biased coin. So Shay throws it 80 times with a relative frequency of 0.75. Nala throws it 120 times and 72 of those times are heads. Work out the relative frequency of heads for the 200 throws. So that's all of it all together. Well, if Nala throws it 80 times and gets a head 0.75 as a decimal, if that's the chance of it happening. So let's find out how many of those would get. So 80 times 0.75 equals... So that's 60 heads for Nala. Shay's got 72 heads. So 60 add 72 would give me 132 heads out of 200. Now I'd expect to get the marks for having it as a fraction, but since in the question it's given it to me as a decimal, I'm going to give my answer as a decimal. So 132 divided by 200, 0.66. Which gives the best estimate of probability for heads? Shay's 80 throws, Nala's 120 throws, or all 200 throws? Well, that is definitely all 200, because the more data I've got gives me better information. So more data gives a better estimate. Something about more data or more trials, anything there that's showing that we know that when we've got more information, it gives us a better chance of getting the probability correct. Right, pie chart question. So a pie chart shows results for some form of sports ball. So I've got won, lost and drew. I'm told that 30 matches were won, how many were lost? So if 30 matches were won, that looks to be 180 degrees to me. Do a quick check on my calculator, is it 180 degrees? So 132 for lost, add 48 for the drew, add 180, hopefully for one win gives me 360, which it does. So if that bit is 30, I think the whole pie chart is for 60 people. So if I've got 360 degrees in my circle and I share that out amongst 60 people, I think that is telling me I've got 6 degrees per person. I'm asking how many were lost, or per game. I shouldn't say per person, should I? It's per game of sports ball. So how many games were lost? So I want to know how many 6s fit into 132. So 132 divided by 6 is going to give me that answer. 132 divided by 6, 22. Right, I've got a scale diagram. I'm told my scale is 1 to 200,000. I'm being asked to find the actual distance from B to C in kilometres. So, just looking at my centimetres first, I think that's 1, 2, 3, 4, 5, 5.5 centimetres between B and C. So I'm going to do 5.5 times 200,000, because that's the scale I'm working at. Excuse me, so 5.5 times 200,000 equals 1,100,000. 1,100,000 now, but that is in centimetres. I'm being asked for my answer in kilometres. So 100 centimetres in a metre, so I can get rid of 2 zeros, and that's giving me it in metres. 1,000 meters in a kilometer. So if I get rid of 3 zeros, that's giving me it in kilometers. So I think my answer is 11 kilometers. Find the bearing of B from A. So a couple of different ways of doing this. I'm going to do it with a protractor. So bearings, measuring from north. So I'm making sure that the 0 on my protractor is in the same place as my north. It's heading that way. Measuring round, make sure I'm starting from 10, 20, 30. No point starting counting from 350. That would be bizarre. Measuring round, that looks to me to be 135 degrees, which is in 3 figures, so I don't need to worry about that. Cracking. Right, I've got a linear sequence. Steady on. I've got a linear sequence. I'm told that the second term is 6 and that the fifth term is 18, and I'm being asked to find the nth term. So I don't know what term 1 is. I know that term 2 is 6. I don't know term 3. I don't know term 4. And I know that term 5 is 18. So the difference between these two numbers is 12, which is 1, 2, 3 jumps. So 12 divided by 3 is 4. So I think I'm going up in 4s here. So 6 add 4 is 10. Add 4 is 14. Add 4 is 18, which is nice. That means that's working, which means that that first term must have been 2. So if I'm finding my nth term, I'm always thinking first about what I'm going up in. I'm going up in 4s, so it must be 4n. And then the way I think about these is to say what number came before the first term, which would be minus 2. So I think that is 4n minus 2. Right, A, B and C share some money. C has £280. C has 2/3 of B's amount. And I know that A to B is 5 to 12. I'm being asked to find the amount for A. So first off, let's have A to B to C. And I know that C has £280. C has 2/3 of B's amount. So if 280 is 2/3, 1/3 must be half of that, which would be 140. And then 3/3, or the whole thing, must be 3 times that, which would be 420. So I know that B has £420. I know the ratio of A to B is 5 to 12. So if I've got 5 to 12, and I know that that chunk there is worth 420, I'm going to do 420 divided by my 12, because that'll tell me what one chunk is worth. One chunk's worth 35. So then if A's got 5 chunks of this, that must be 5 times 35, giving me an answer of 175. So A has got 175. Cool. Oh, Venn diagram. Those wonderful little circles. So I've got this Venn diagram. I've got an unknown amount there. I'm being told that the probability of getting A is a half. Find X. Well, if the probability of getting anything in that circle is a half, and there's 50 people in there, I'm willing to bet I've got 100 people altogether, or 100 things altogether. So if 30 or 20 is 50, I've got 6 on the outside, I'm up to 56. I think there must be 44 people in that bit, because then that all adds up to 100, and then that is 50 out of 100, which is half. So I think X equals 44. Right, Pythagoras theorem question looks like here. Find X. So if I want to know that side, I need to know these two sides. I don't know that one yet, so let's find that one. So if I just draw this triangle out again, I know that that side's 12, and I know that that side's 13. I like to draw squares coming off of mine, or what will pass for rough squares, because it reminds me that the two small squares add up to make the big square. So 13 squared is 169. 12 squared is 144. So if I want to know the area of that square, I'm going to do that one, take away that one, which will be 25. Square root of 25 is 5, so I know that the length of that side is 5, so let's just pop that back on my drawing up there. So now I'm ready to find that long side, that hypotenuse, so I'm just going to sketch that out again. If that side's 5 and that side's 9, again, just draw my squares to help me think about it, because the two small squares add up to make my big square. 9 squared is 81, 5 squared is 25. If I add those together, so 81 add 25 is 106. So if I want to know that length, I need to square root that. So the square root of 106 is 10.29563014. So I'm not sure what degree of accuracy they were after here. I'm sure they probably did want that rounding, but that is the exact over precise value of x. Right, give an equation of a line parallel to y minus 2x equals 9. Now I like mine in the form y equals mx plus c, where we know that x is the gradient and c is the intercept. So let's change that into this form. So I'd add 2x, so I've got the y on its own, so y equals 2x plus 9. If I want my line to be parallel, I'm going to say my y equals 2x, and then you could write plus anything here, you could write minus anything, y equals 2x plus or minus anything, or even just y equals 2x would be parallel to it. So anything where you've said that y equals 2x. Right, if I have a straight line graph that has a gradient of 5 and it goes through 3, 7, which line is it? And then I've got some options. Well, if my gradient is 5, that's the bit that goes with the x, so it ain't that, and it ain't that. That's my x coordinate, that's my y coordinate, so we know that it's going to be y equals 5x plus c. I know that y is 7, because that's in the y spot. X is 3, so 5 times 3 is 15. What do I do to 15 to make it 7? I take away 8, so it must be that one. Hope that was useful, guys. Do let me know how you got on. If you've got any questions, I'm normally very happy to answer those. I probably will be this time as well. Yeah, give us a shout. Cheers.